Hi, in this video we're going to look at equations of straight lines. This is a GCSE higher and foundation topic. It's generally regarded as a grade C topic. In this video we are going to be able to understand what's meant by the general form of an equation of a straight line. In this form here, y equals mx plus c. We're going to explain what this means. We're going to be able to work out the gradient of a straight line, and finally we're going to be able to work out what an equation of a straight line is just by looking at the graph, by working out a couple of things. Okay, these are really important types of topics, and certainly important to be able to do gradient and equations of straight lines in the GCSE exams, and more often than not these questions are built into something else. So it might be to do with an exchange rate or to do with a conversion graph. It might be part of a scatter graph. It could be thrown in terms of a different sort of question, but you still might be asked to work out an equation of the line or the gradient or both. Let's look at this first example then. In this example here we've got a straight line and it's going up here, and I've got a set of axes as well. I've also shown the grid, and more often than not you'll be also on an exam paper be able to see the grid lines to help you out with this. I've also put over here y equals mx plus c. Now this is really important. There are two key parts to this. There's the m part, which is going to be a number, and this is going to stand for the gradient. So we're going to have to work out what the gradient is. That'll give us a number, and we can put that in front of the x. And the final part, the second part over here, is the c. And this is the easiest part. The c is the y-intercept, or where it crosses the y-axis. So y-intercept. Where does the line cross the y-axis? Now, in this first question, what we've got here, this first example, we can quite clearly see that the line crosses the y-axis at -1. So the value of c, we can say straight away this value here isn't plus c, it's actually -1. So let's start building up our equation of a line. So we've got, so far, y equals something x, and we're going to work out the something in a minute, -1. And we know that from here, just simply looking to see where the line crosses the y-axis, the y-intercept, where it crosses the y-axis. Okay, now to work out the gradient is the steepness, how steep this line is. And we can see a few occasions here that the line crosses some coordinates. We've got here, we can see it crosses at -1, -3. It also crosses, where I circled before, at 0, -1. It crosses at a coordinate 1, 1. It crosses at a coordinate 2, 3, and 3, 5. And there'll be lots of other places further up this way and further down in the other direction where this equation of a line will cross at coordinates. Now we're going to use these coordinates, these locations, to help us work out the gradient of the line. You will see that where it crosses here, it goes 1 along and 2 up. And again here, 1 along and 2 up. 1 along and 2 up. 1 along and 2 up. It does this all the way. It has the same property all the way along the line, in this idea that it goes along 1 and up 2, along 1 and up 2. And we can use this information to work out our gradient, to work out the steepness. What we do is, if I put some numbers next to this, and it goes along 1 and up 2, we can use this idea that it's changing in the y direction 2, so changing here 2 for every 1 along. And the proper way to think about this is it's a change in the y direction divided by a change in the x direction. So a change in y divided by a change in x. Now, more often than not, you'll be able to remember this, and that's fine. I often, when I was learning this, I used to forget which way round it was, and I couldn't remember if it was x over y or y over x. And then a more American way of thinking about it is something called rise over run, which I've started to use more myself. I find it easier to remember. So rise over run. How far up or down did it go compared to how far across it's gone? Again, we get exactly the same numbers, 2 and 1. So in this case, we can say that the gradient is, well, it's gone up 2 and along 1. 2 divided by 1. Well, 2 divided by 1 is just 2. So I can change my m that I had here for my gradient. My gradient is 2. So my final equation of line is y equals 2x minus 1. And that's all I need to do to work out the equation of a line. I will think about where it crosses the y-axis, that was minus 1, and how steep is the line. Well, the steepness is given a number, and the number here is 2. That's because it went 2 up for every 1 along. So 2 up here for every 1 along. Okay, let's look at another example. In this example, we're going to do the same thing. We're going to find the equation of the line and put it into the form y equals mx plus c. I'm hoping you've already spotted where the line crosses the y-axis. This time it's at positive 3. So straight away we know it's going to be y equals something x plus 3. I've got some marks already for identifying a key part of this. Now the gradient is the next part. Okay, let's look at the gradient. I'm just going to rub this out. The gradient then is where it crosses the nice coordinates that I can pick easily. Now we can see that it crosses all the way down here, but not at a place that I really know what the coordinate is. I know here, okay, so I'm going to highlight this as being a point that I'm interested in. And then when it following the line up, I still don't really know what this is. I might have a guess of it being a half, but I don't know for certain. This looks like it might be, I don't know, 3/4, but again I don't know for certain. But here, I do know. I do know this point here is 1/7. So I'm going to make myself a little triangle, starting at 3, going along, and up here. And when we use this for my idea of rise over run, or the change in the x direction and the change in the y direction, I've gone 1 along and 1, 2, 3, 4 up. So remembering what I said before, we've got rise and run. So 4 over 1. 4 divided by 1 again is just 4. So the gradient of this line is 4. So the final equation of the line is y equals not mx plus c, we've worked out that m is 4. So 4x plus 3. Okay, another one, done. Let's look at a third example. Okay, this time you can see that the line isn't as steep as the last one, but we're going to do exactly the same thing. So let's think about our y equals mx. Let's look at where it crosses the y-axis first. When it crosses here at positive 1, so y equals mx plus 1. That's the first part we can do. Then we need to think about the gradient. And again, we're going to trace along to see if we can find some nice coordinates. We've got one here at 0, 1. Not really sure what this is. We've got another one here at 2, 2. And 4, 3. And 6, 4. And you can use any of these. Last time I just chose to do one triangle. Actually, it doesn't really matter if I can choose this triangle here, or if I prefer, I could do a larger triangle. It actually works either way. Let's do the larger one this time. Okay, so it goes along 1, 2, 3, 4, and it goes up 2. So again, thinking about the fact that my gradient, the letter m, is rise over run. or, if you prefer, a change in the y direction divided by a change in the x direction. Well, the rise this time was 2, and the run was 4. It's actually given me a fraction this time, 2 over 4. Now, I know that 2 over 4 is the same as a half, so I'm actually going to write that in as a half. Okay, so this time I've got y equals a half x plus 1. And that's okay. We're not always going to get whole numbers as our gradient. It's not always going to be 1 or 2 or 3 or 4. Sometimes we might get a half or a third. A third, incidentally, have a little think about it. Where do you think a third might go on here? I'm just going to sketch it in a second. If the gradient was a third and it still crossed at 1 on the y-axis, roughly where do you think it would go? Okay, I think it would go something like this, where we go 3 along for every 1 up. Okay, so 3 along for every 1 up, if it were a third. So again, we can have fractions as gradients as well as whole numbers. Okay, let's look at one final example and then you can have a go by yourself. Okay, in this example, the line still crosses the y-axis, so let's start off in the same way that we've done all the others. Let's have y equals mx. It crosses here at -2, so -2. Again, we've got a mark already for working out the y-intercept. Now the gradient this time, you'll notice it actually goes in the other direction. Again, I'm going to trace along to see if I can find some nice coordinates. We've got one here already, so I might as well use that one. Where else could we do? We could have here, or if you prefer up here. I'm probably just going to take this one. So let's just mark on our little triangle. Okay, so we could do it that way. Or, again, if you prefer, we can do it this way. It doesn't make any difference at all which way round we do this. What we do need to do is just be a little bit careful of what's going on this time. Now, we've always talked about rise over run, but this time I'm moving, again, I'm thinking about this, thinking from left to right. From left to right, my run, I've gone along one, oops, I've gone along one here, but actually I haven't gone up at all. I've actually gone down 2. So I'm going to do that as minus. Instead of going up in the positive direction like we were doing before, I've actually come down this time. So I've gone down 2 for every 1 that I've gone along. So again, thinking about my rise over run, my rise actually is negative this time. So -2 over 1. Again, just introducing a little bit more complexity here. -2 divided by 1 is still -2. And again, we can have both positive and negative gradients. So this is y equals -2x minus 2. It turns out that negative equations of lines always come in this kind of direction. These are always negative. So just look out for those. It's easy to make a mistake and just do that as 2 divided by 1. If it's coming down from top left, down to bottom right, it's in the negative direction. Just remember that it's not a rise, it's actually a fall. Okay, there are 2 lines that I'd like you to see if you can work out the equations of them. The first line comes down here, this way, and the second line is in the opposite direction, coming up here. Pause the video, have a go, and I'll explain what the answers are in a second. Okay, so hopefully with the first one, you'll have noticed it's negative. Let's have a look for some nice coordinates. It doesn't matter if you didn't pick the same ones as me, and mine again are only little sketches, but I've gone along 4, but down -2. So thinking about my rise over run, I've got -2 divided by 4. That gives me a gradient of -1/2. And I have a y-intercept of -1. So this first one down here, we'll label that up as y equals -1/2x minus 1. The second one is in the positive direction. Again, I can see it crosses at +1 here, and if I draw a small triangle, we can see it goes along 1 and up 3. So rise over 1, 3 over 1. This one has a gradient of 3. So 3 over 1 has a gradient of 3. This one will be y equals 3x, and it crosses here at positive 1 plus 1. Hopefully you got both of those right. If not, just go back and have a quick look at see how we worked out the gradient again on those previous examples. Okay, so in all the videos that I've done so far, we've been making revision card notes. If you want to make some revision card notes here, then maybe a quick sketch of what some equations might look like. So you might want to do something like this, noticing that this is in the positive direction. You could highlight where the y-intercept is. So this would be the c part of your y equals mx plus c. You could talk about your gradient being changing the y direction divided by changing the x direction, or if you prefer, rise over run. And again, on your little picture, you might want to show how you've picked some coordinates, made a triangle, explained how you can do the change in the y divided by change in x, or the height. You might say that this is 4 and this is 2, which would give a gradient of 4 divided by 2, which is 2. Okay, and that gives you gradient, which is the m part here. This is your gradient. Okay, you might want to draw yourself out another little picture that shows it in the negative direction. Whatever works for you. Equations of straight lines are quite nice once you get over the fact that it is simply just y equals mx plus c. You've got two things to work out. You've got the y-intercept and the gradient, and you can calculate the gradient in one of two ways, but either way you're going to get the same answer. Check out my other videos for other revision topics. I haven't done one yet in terms of plotting straight lines, but I'll do that next. Have a look out for it. Good luck with your exams, and fingers crossed for you.